So thanks for joining and being here. So today we're going to talk about the OWASP top 10 number one. So last week we talked about injection. Talked about injection first because it's a favorite subject of mine. But it also used to be number one. Now it's further down the list. And broken access control is number one in that list. If you guys joined the last session, we looked at the OWASP top 10 briefly of common or high risk areas to look at for application security. Injection was number 3. You were looking at number 1 today, broken access controls. Okay. If you wanted to see last week's presentation, actually Lauren, who helps run these sessions, put it on YouTube, so you can go and take a look at HackForge. There it is, how to protect the code against injection attacks. So it's all there. Last week, 58 minutes. And then HackForge is actually posting all of their sessions here, so you can go and see a whole bunch of other stuff that they do. A lot of it's like open street map stuff lately, because there's a open street mapping for cycling project going on. There's some database work that's also going on, so you can learn about data management and data manipulation. That's through another interest group called Border City Data. So there's lots of interesting stuff there. Yeah, go take a look. If you're wondering why my subscriptions all look like I have small children at home, it's because I have small children at home. So there's all their subscriptions. Anyway, so let's take a look at broken access control. So we're going to give a brief introduction to broken access control. We're going to look at Chatsploit. If you remember, Chatsploit's our application that is very poorly programmed, follows no good security practices, and that is that it's just the application that we're going to pull apart during these sessions. Last month we showed that it was susceptible to a whole bunch of injection attacks. We'll actually be doing another injection attack near the end of the presentation because we ran out of time last time. So we're going to look at cross-site scripting, which is like client-side injection. Interesting case of injection. We'll look at, but today we'll look at Chatsploit and how it doesn't have very good authentication enforcement. We'll look at how it doesn't have very good authorization enforcement. And then we won't look at a demo but in this area of broken access control, there's another thing called XSRF, cross-site request forgeries. So we'll talk briefly about that. And I don't have a demo for that because it's actually kind of, it was more work than I had time for, unfortunately. But we'll talk about the theory on that. You guys can go research it. Chatsploit, though, is susceptible to XSRF attacks. So I'm posting this code to my GitHub. That's github.com/John Haldeman. No dot there, just John Haldeman, one word. And you'll see that that Chatsploit's up there, and XSRF is a you can launch an XSRF attack if you wanted against it. All right. So once you know the theory, you have to take a bit more research into that and how to do it. Okay. So what is broken access control? It's the number one on the OWASP top 10. It's very broad, right? So a user can do something they should not be able to perform, which is extremely broad. So that's and it's a little bit weird, right? So an injection is a user breaking access controls by you performing a certain kind of attack on the system that lets the user, exposes the user to information that they should not have, or lets the user do something to the database that they shouldn't be able to do out of band. So that's kind of a broken access control, right? The thing is about this is just categories, right? So injection. So the if you and unfortunately, like, they keep getting bigger in OWASP, and so you'll see that the if we go to OWASP 10, we look at broken access controls. You'll see that it's actually, there's 34 CWEs. CWE is a common weakness and exposure, which is a set of application risks built by MITRE. And so you can see that there's 34 of them, and there's a whole bunch of different ones, right? We're gonna talk about like missing authorization, incorrect authorization, some of them today, but there's also like a whole bunch of other things that might happen. These are very broad. I think there's a lot of pressure. I'm not part of OWASP, so I can't speak to them. But if I was to guess, these it seems like these categories get broader and broader as time progresses. And that's because there's more and more pressure on them to put in the top 10. Every serious risk, and there tends to be a lot. And so it's interesting because the top 10 is supposed to be something that simplifies application security, like a model for making applications more secure. But there's also this pressure to make it extremely broad, which kind of like muddies it. So anyway, I'm gonna do the ones I see most often in today's demonstration, and they're very they're common, but they're also very sort of easy to understand. So they're not sophisticated. You'll see. Okay, so what's the difference between like broken access control and some of the other things? So like broken access control is like the locks on your door are weak. You didn't do a good job of building a good door or a good lock. And while injections, like, so you did a great job on the door, but they climbed through the window, right? That's the kind of, you can kind of build mental models around that. So the functionality is legitimate, but the controls are too loose. All right, so let's look at absent authentication. So one of the things that it goes on is that you build an authentication into your application. So someone has to log in. For instance, if I click find friends here, right? Goes, tries to load the page, realizes I'm not logged in, and wants me to log in before I'm able to search for friends, right? So let me, actually, I think it's John H. Let me log in here. And yeah, it's just my passwords in this application are terrible because everything's terrible. So I'm logged in as John H, right? And at least I'm authenticated now. It knows I'm authenticated. And so now when I go to find users, find friends, I get the page, and I can do, this is the same thing we looked at last month, right? So this is the interface, right? So this interface where I go and I'm able to find friends is behind a login page. Makes sense. You can't get to this interface without going through the login page. All right. So this is a application that is a JavaScript application, very popular. Like they call this like a single page web app. It's built in React, and the back end is Node. So fairly modern. But and so how this works is this all runs in JavaScript and HTML on the front end, and then it makes backend calls through an HTTP API. So like if we search here, you can see, okay, so it makes a call to API app user and searches for J, right? So we're searching for J. If we go H here, you can say, okay, there you go, JH, like John H. You can see it's search inside the path here. it's making a HTTP call. So it's making a HTTP call to localhost API app user John H. Okay, makes sense. So, and this is behind a login screen. The question is, okay, so if I just go to here, you can see it's just a GET request. So I can go here and see, okay, so this is the results of the search been in JSON, right? So I'm seeing the JSON results of the search. This is just through the API, right? So this is the inspection area for Chrome. If you go, you can right click and click inspect to get to this, and then look at the calls through network. So anyway, so I'm here, and you can go and, okay, so this is how the web application works. So the question is, do I have to log in to actually get this? Let's see. So I'm going to create an incognito window, and let's go to localhost 3000 again. Make sure I'm not logged in. So if I go to find friends, the web application realizes I'm not logged in and redirects me. And so then I'd have to log in. But I'm not going to log in here. Instead, I'm just going to go to the API endpoint. So the problem here is, while the user interface tries to authenticate me, the API endpoints where all the data are, all the data is there is no authentication. And so this is one of the things, one of the CWEs, right? Is that, okay, so things that you should be authenticated, there's another way around the authentication, right? But my controls are there in the app for most people. But then anyone can circumvent that control by just hitting the API directly. There's no authentication there. And so what I need to do is I need to make sure that my API is protected in addition to my UI. So my back end has to be protected. And so this is happening through the search area. So if you this is a Next.js application. How Next.js works is the stuff that runs server side is underneath this API folder. So everything that's under API is running server side. This is my API. It's JavaScript here, but it's just JavaScript running on the server, not in the browser. And so I have this search interface, and you can see that it just does this, and there's no checks. It goes and gets the query and searches for the user and returns them, but there's no check to make sure that the user that's requesting this is actually authenticated. And so to do that, I have to put in the check. So now I'm going to put in, so we're going to go get the login session, find the user to make sure that so over here, this get login session uses the JavaScript web tokens. It goes and gets the token cookies. So the tokens are part of the cookie, the cookies that get sent. Let's see if I show you that. So when we made this call, you can see this token here. So this is a token like generated by my authentication plugin. It's Passport. Right, and then there's the token itself is generated throughout some other stuff, but that's not really important for this discussion. We'll talk about that a different session. What's important is, okay, so it gets the token and then it finds the user, and now if we have a token and we have a user, if we don't have a token or we don't have a user that the token correlates to, we say, okay, so the token's invalid, so please log in. We give this a 401, right? Or if there's just an error, you don't want to let them do the work anyway. So if there's any kind of error, also give them a 401, right? So we're going to do this. We'll go back. We'll save this. It automatically compiles and will run in the background. So if I go to my incognito window where I'm not logged in now, and I refresh, and now it will say, okay, my authentication token's invalid. Please log in. Whereas if I go back here, where I am logged in. So this is not this is when I'm not incognito. This is where I'm logged in as John H. And I refresh this the same API call. You can see it works. So now, not only is my front end checking if there is a user, my back end is also checking that the user is authenticated. You have to do it in both areas. This seems obvious, and it should, but I see this all the time, right? And it's very easy to fool yourself as an application developer, where the front end, because that's what you're using all the time, does something, and then they don't check to make sure that the API is also enforcing the same controls. In this case, authentication. Okay, so now I'm gonna, that's authentication, for absent authentication. I've got another demo, absent authorization. Before I do that, any questions? Okay.
I have a question.
Go ahead, Josh.
All right. Yeah, so this is the kind of stuff that you wouldn't be able to fix with like a web app firewall, right?
Yeah, so it would be, I guess you could. So with a WAF, you could check to full. You could do basic stuff, like you could confirm that there is a token present before you let them execute the API. If you have the WAF in front of the API, that isn't a very great control though, because they could just fudge the token. And it'd be hard, I think, to have the WAF confirm the token. It depends on the WAF. Probably not, but it's probably something you don't want. This should be basic inside the application. So the best place to do this is inside the application code. WAF, I guess, could give you some additional protections for other things. It's also like, so injection, we spoke a little briefly about WAFs, and the best place to capture injection is to change the application code to protect against it. And then like a secondary thing is because people are fallible, right? You can set up a WAF to try and catch all the sort of holes that people have left, but you don't want to like rely on it. Hopefully that answers the question. That's not the first place I would go. But if you're maybe aware of an issue, maybe there's a 0-day or something like that, then you can start to maybe add WAF rules to check for certain things, check for certain holes and fill them. But it's kind of like putty, right? Rather than putting up new drywall. Any other questions? That was a good one. All right. Yeah, thanks for that, Josh. Okay. So for those on the line, this is a diverse group. If you're wondering what a WAF is, a web application firewall. It's a thing you put in between your users and your application to add additional protection. Like the name says, it's like a special firewall. It's an application-aware firewall. So it knows what an HTTP header is. It's able to inspect those headers and HTTP calls, and then if it sees something that shouldn't be right, they can prevent those from getting to your web application. So good. All right. Good. So the fine friends. Okay. So the next one's okay. So that's absent authentication. So my user isn't authenticated. The next thing is, okay, so if your user's authenticated, are they only able to do what they're supposed to in the application? So authentication aside, would they, for example, would one person be able to see another user's messages to someone else, right? Or another person's conversation. So if we go chat here, and we'll bring up the API again. All right. So one of the things that this application does is it loads the set of conversations, the history of conversations on the left, when for the user that's logged in, right? So that's what happens here. Get rid of some of, well, I'll just make this really big. All right. So we have a conversation list API call, right? And so this is, it goes to API app conversation list and gets the conversations for this user, happens to be the user that we're logged in as, right? So this is the user ID. So this says you have a conversation with another user, different ID. You can see this is D8E03. You have a conversation with 1D43F. Their username is JBean and their name is Jellybean. So okay, so that's the conversation, and then I can click on them, and it will load the chat I had with Jellybean, right? So that's all good. So we just it polls, and so we're just gonna refresh that so it doesn't poll forever in the background there. So the okay, that's fine. So the question is, so this conversation thing, you can even double click on it, right? Whoops. Let's stop recording. Okay. So this conversation list. So the question, okay, so do I have controls on this conversation list? And my controls on this conversation list, if I go to my incognito window here, and I try and access the conversation list, is, okay, well, at least I got this control. So user has to be logged in. So this is the conversation list for John H. The user has to be logged in order to see the conversation list for John H. That's great. So this API endpoint at least has an authentication check. Question is, okay, so if I log in as JBean here, which is not John H, I'll log in. All right. So I'm logged in as JBean, and the only person JBean has a conversation with is John H. And so if we, the question is, okay, so the JBean should not be able to see the conversations that John H had. So, but if I refresh this, I'm actually able to see that the only person that John H has had a conversation with is myself. But I shouldn't be able to see their conversation list. That's private information. And so while the API endpoint here is secure and makes sure that the user is authenticated, the API endpoint here is not making sure that the user is authorized. So they're able to see, they can't see it through the UI, right? The UI restricts what they're able to do because it's interactive. But again, they can go into the backend APIs and just execute what they like, because those are exposed in these apps. And so okay, so they can see something here and they're not supposed to. And so now we have to plug this hole too. This is absent authorization. Again, very common, but simple to understand. And so this call over here, right, where we had 401, right, the authentication tokens invalid. We're going to add a little bit more code here. So if we can't find the session or if we can't find the user, we said the authentication is not valid, but we have an additional check. We're also going to check if the user in question, that's the user that who is associated with the token that's logged in, if the user ID they request in the HTTP API does not equal that same user, then we give them a 403. We say the logged in user is not authorized to view that resource. So this was HTTP 401, which is, you're not authenticated. Log in. 403 says you're authenticated, but you're doing something you're not allowed to do. Right? And so now if I go in my incognito window here and refresh this, I should get a 403, and it should say the logged in user is unauthorized. There you go. So they can do stuff. They can perform other APIs like we can if I refresh this page. Here. Static development. Yeah, here, my conversation list. I can see my conversation list through the API because I need to, because that's what my front end relies on. I can see my conversation list, but I'm not able to see John's conversation list. In this case, I'm JP. But John is able to see his own, and his application still works. So simple things like this, again, you can it's a simple thing, but you can fool yourself very easily into thinking that your application is secured, but you're not. This is actually extremely common. If you watch the news, if you read the news a little bit in information security, there will be lots of examples of people just changing numbers in their URLs and getting access to things that they're not supposed to have access to. It's extremely common. This is part of the reason it's #1, right? It's not a default. It's something you have to build into the application because it's not a default. You have to be a little bit careful and not fool yourself. Okay, this is another reason why you have external people to sort of test your security. So one of the ways you can prevent bad things happening to you is through penetration testing. You hire an external party to try and find holes inside your application, and a lot of what those people do, I mean, doesn't have to be sophisticated. It can be enumeration attacks like this. Just hit all the endpoints with a bunch of things that you know is relevant, but make sure that the application responds appropriately. Okay, good. So that is absent authorization. Any questions? Okay. This is easier than injection. It's a little less abstract. Okay. So we're going to talk about something more abstract, cross-site request forgeries and cores. All right. So I'm cheating. Cores is not as so cross-origin something. Cores. Cross-origin resource sharing. All right. So cores, problems with cores, and when some people will talk about cores, is actually in OWASP. In configuration, in OWASP 5. So the security misconfiguration. Cores is in there. If you click on that, search for. I'm pretty sure it's in here. This is 2021. Yeah. All right. I'm pretty sure it's in here. Maybe it's called something else in here. But the maybe they name it something different. But the cores is in a different OWASP category because the ones in this category are stuff that's sort of non-default. By default in cores, you get a certain amount of protection. In CSRF, you get no protection. But they're very closely related, and so I want to talk about them at the same time. All right. So CSRF and core. So what's the problem we're looking to solve? So we already talked a little bit that we log in, right? And we get some cookies, right? So we get some tokens to show you the tokens inside the web browser. Those identify the user as a certain person. And then you can you can authorize against that person, right? So we get login. You do the login process, and you get a cookie as a result. This is the user's browser, and so you go to Chatsploit and get your cookies, and then the user in another tab, right? Or just maybe they navigate away from Chatsploit, but their Chatsploit still has their browser still in memory has a cookie related to Chatsploit. They go to a malicious website, a website that someone has set up in order to in order to steal or cause mischief inside Chatsploit. So they go to a malicious website and they download a nasty form or some JavaScript, and they perform a malicious action. How do they perform the malicious action on Chatsploit? Well, they do it via the browser, and the person with the browser has a cookie that allows them to do certain things. And so the malicious website, for example, let's say Chatsploit's a chat application, so maybe it goes and generates a whole bunch of spam messages, right? So it goes and spams a bunch of people with a whole bunch of scam messages for their users, right? So the malicious website would do that via the browser. So that's sort of, this problem is what we're trying to avoid with appropriate use of CSRF and appropriate configuration for cores. So CSRF tokens, what they do is you go log in to Chatsploit, you go to the malicious website, you download the nasty form that tries to, which basically submits an action to Chatsploit, tries to perform a malicious action, but then the back end in Chatsploit says, oh, that malicious action that you got from the malicious website, it doesn't have a special thing that I give my users, that I generate for my users when they log in or when they're about to perform an action. It doesn't have that special string. And so I know it's not a payload, it's not the web application that my users that I gave my users performing the action. So it performs an invalid, it checks and says, okay, so you have a XSRF token, but the token's invalid and prevents you from doing something. So that's a CSRF. That's what CSRF does. It's primarily concerned with data integrity, preventing actions rather than data leakage. Why? Because cores is mostly data leakage. We'll talk about cores coming up. So it's needed. Okay. I thought I had. Okay. So that's how CSRF tokens work. I thought I had another slide here on cores, but it's been a tough week. Okay, so how cores works is what cores would do, interestingly, okay, so what cores would do is, instead of doing any of this, so let's actually create a new slide here just for cores. So what cores does is the same thing, right? So you get login and cookies from Chatsploit, and they go to the malicious website, and so over here it's not really about the form. They perform, they get some nasty JavaScript, and what the JavaScript does is it says on the browser, and says it's like there's a pre-flight request. So it says the request from is from, so this is malicious website.com. So it says, okay, so the request, this JavaScript is from maliciouswebsite.com. and so it wants to perform an action. And so I'm going to pre-flight this and say the request is from malicious website website.com. Is this okay? Right. So it says okay. So that's the pre-flight. Is this okay to perform this action from malicious website.com? Chat, and then what ChatSploit says is sends back to the driver, sends back to the browser. It says, like, it says, okay, so that's the pre-flight. It goes, it says no way, right? So it and then the browser says, okay, so the browser it will just send a message back to malicious website saying, nope, not going to do it, right? So that's the this pre-flight thing is sort of a Core's is sort of the Core's way of doing it. The question inevitably is, this seems like a better mechanism, so why on earth would you ever have CSRF tokens, right? So this implies that an action is actually going to Chatsploit, right, before doing some kind of execution. And then where maybe we should always just pre-flight. And for the vast majority of requests, this will actually happen. For the vast majority of modern web browser requests, pre-flight will happen. The pre-flight, like, it's an options call to the web server to make sure that it's okay to perform the action from the source of the script. There's certain actions, because of sort of legacy reasons, effectively, that do not do a pre-flight. They're sort of form actions. That's why this is specifically a form. There's certain actions that that do not do the pre-flight, and so you still have to block against those actions using CSRF tokens. Okay, so that's sort of the difference here. Core's CSRF sort of has always been around. And the idea is, okay, so you prevent action by giving users tokens, and then Cores is you sort of prevent leakage. It's mostly about leakage, but they're very closely related. Any questions on Cores or CSRF tokens? Okay, that was heavy theory. I apologize. All right. Yeah, okay. And I can't believe I didn't have that slide. Anyway, we made it on the fly. Okay, so the last thing I wanted to talk about today was injection. We have 15 minutes left, and so we didn't get to injection last time because we ran out of time. We didn't get to cross-site scripting, a special form of injection, last time because we didn't have time. So cross-site scripting, I wonder if I have, okay. So cross-site scripting is a mechanism to sort of perform JavaScript actions through the web browser on someone else's web browser by giving your website a payload that's sort of bad. Okay, so it's easier to sort of show this. So if you say if we start typing in messages here, right, and send. Okay, so like there's a new feature, right, in Chatsploit, right? You can now use HTML to do expressive. It's interesting. It's not working. Okay. All right. So we now do HTML to do expressive things. All right. So like strong. This is bold. You see? All right. So you know, you can go like to xkcd, and you can copy this link address, and so okay, you can go image source equals this, and didn't actually test that. So okay, that's not the copy image address. What do we want? Okay, there you go. And so inside Chatsploit now, you can send images by giving people HTML tags, and you can bold things, right? So HTML is very expressive, very cool, right? And so this was a great new feature idea that they decided to put into Chatsploit, so so that anyone can have use HTML inside of the chat messages. Hey, very cool, right? So the problem with this is there's certain HTML tags, like we were talking about the image tag, where you can sort of force it to execute JavaScript. So, for example, so we have an image here. I mean, it's going to give it a source that doesn't exist, kind of like what I did here, right, with this broken image. And then on error is a thing inside the image tag. So if we go to image tag on error, so if we go, if you look at the image tag and you read up on error. So image loading errors, right? So if an error occurs, an on error event handler gets set, and it allows you to execute an event handler, which is effectively JavaScript. So this is a piece of JavaScript. This is an alert, right? So this is going to send an image on error, and then it's going to put it in here. It's going to put it in here hacked. It's okay if he hacks himself. The question is, what about the person he's chatting with, right? So this is Jay Bean, right? I just sent a message to Jay Bean, and it had some JavaScript inside it. That's interesting. That's interesting. Does that not work here? Let me refresh this. That's interesting. I wonder if it's because I'm in an incognito window. So it's not actually running the JavaScript. I wonder if it's because I'm incognito. That's actually unexpected. Anyway, so the idea is this would run without this interesting protection. Maybe if I'm out, let's try Firefox. All right. Separate browser. I swear, I do try these things before. Con, yeah, all right. And it's like in dark mode, so it's going to look really weird. No, it's there. Oh, you know what? Maybe I don't have the unsafety. Okay, hold on. So I'll show you where the problem is. So effectively, I think I may have actually sort of resolved the issue inadvertently when I was testing this out, because I sort of want to talk about it. All right, so we have inside chat, inside ID, we have the chat component. Let's go look at it. Okay, so yeah, okay, this is okay. So how it's supposed to, so this is actually the okay, this is the fixed version. So let me replace that quick. Yeah, okay, there it is. Okay, and there's the hacks. All right, so actually I had the fixed version. I put in the fixed version. Okay, so this is the area inside inside the code, inside our application code, that is causing the issue, and it's this actually very well named dangerously set inner HTML. This is actually part of JSX and React. This is actually just called like set inner HTML in other JavaScript areas. They've prefixed it with dangerously set inner HTML so that you know you're doing something here that's dangerous. The dangerous being is you're exposing yourself to cross-site scripting attacks, right? So another way to do this is what you saw before, right? Where you don't do the dangerously set HTML, you use regular like React code to put in the prop sub message, and in that case, it just looks like this, right? So all those things get, all those HTML characters and that kind of thing get escaped. The disadvantage is now you don't have that functionality in your app, so that we don't have the functionality to send HTML to each other in the app, right? So that is that's the way to get around it is to like never use raw HTML and that your users input inside your web application, because if you allow them to use raw HTML, like then they can go and execute arbitrary JavaScript. If they can execute arbitrary JavaScript, that means they can execute things on behalf of other users that are using the system. So John, using his image tag with the on-error handler, can go and send messages to other people that impersonating JBean, right? Because he can just put it inside the JavaScript. It will use JBean's tokens and then execute the calls. Okay, so that is so sorry about that. That was a little anyway, but that's the fix. The fix is just do this. If you still wanted to send images, you have to do something separate. You have to provide a different mechanism to allow your users to upload an image and then display them. This is why you don't see in many places at all users entering raw HTML and then displaying it. There was a time on the internet when that was common, right? And then we sort of learned our lesson, and no one does that really much anymore. So don't put anything inside your don't put any user input inside unsanitized HTML. Always make an escape. How I would do this if I was doing chat support for real is we'd provide some other interface to upload images. If we want to do bold and that kind of thing, we can do like what Slack does, right? With the give them a separate we can do the star thing, right? And then give them like a separate language to learn what, and how we'd have a processor that would take this and then convert it to a bold string. We have to be very careful with that processor because we don't want to have them escape. but you would do something separate like that. Maybe you could use Markdown. Markdown's very popular, and there's a lot of good Markdown processors on the web. Okay, we got 5 minutes left. We did what we wanted to do today, which was broken access controls and a little bit on cross-site scripting, flavor of injection. Is there any other questions from the audience?
So what is the core, like all that's connected to the cross origin policy, right?
Yeah.
Okay.
Yeah, so for cores. So for cores, there's a cross origin policy. And so by default, everything's blocked except the origin of the the website where the API is hosted. Right. So by default, cores is always set up so that you're very well protected. The reason it's in a different part of OWASP is that there are options to loosen that, and you can in the cross origin policy you can say, okay, loosen it so that all websites can do it. And you might do that if you're like in a rush or you don't know what you're doing, right? So it's actually, that's why it's part of security configuration, is because misconfiguration is because by default you're well protected, and then there's an option that you can set a bad default to sort of go through to allow APIs that maybe you shouldn't allow for cross origin sites that you don't trust. Yeah, but that's a good question. XSRF, yeah, it doesn't have much to do with the origin at all. XSRF, it solves the same problem, but you're using tokens there instead.
Thank you.
Yeah, thank you. Good question. Any other questions? All right, thanks for joining.